Hello, welcome back. We're doing Chapter 5, Section 1, Identifying Linear Functions. In the previous videos, we looked at graphs of things that could be linear functions. And then in the second video, previously, we looked at tables, and do the tables actually show a linear function? And now we're going to wrap it up with equations. And we're going to try to figure out if I have an algebraic equation with f of x equals or y equals. That we're going to, if we can tell if that's going to represent a linear function. Don't panic too much about changing between the word expression and equation. That's a subtle difference that that's going to be a little difficult to explain if we're not having a discussion in class. So just by listening to me in the video, I don't know if I'm going to explain it really well. But essentially, expressions just have variables and constants and operations. Equations say an expression is equal to an expression. So a lot of times we're going to see an equal sign, and yes, it'll be an equation, but technically, and there I am being a real math nerd, technically, if I have like a algebraic function where it says f of x equals or y equals, even though there's an equal sign there, it's really not an equation. And I had a professor who identified this, and we talked about it a long time ago, and I always remember what he did. He wouldn't use an equation. He used like a well, actually, he wouldn't use an equal sign by itself. He used like a colon with an equal sign. But I think that's a little bit too much for what we have here. I just want to make sure that like I'm telling you, I'm speaking the truth. But it's probably a little bit too much for what I need to do here. So don't panic too much about that. All right. When we talk about this section, we're going to introduce this. This is called standard form. And to be honest, I don't even like the fact that we call this standard form. It's very useful, and there's a place for it. It comes from like when humans first started to learn algebra, but it doesn't fit with what other things that we call standard form. But it's okay. I'll get that when we get to the next one. Standard form basically says this: you're going to write something times x plus something times y equals something, and the something, this something, that something are all just numbers. Don't worry about the fact that it says real numbers. For right now, all the numbers you know are going to be real. Later we'll talk about numbers that aren't real, but don't worry about that. All right? And you can't have both a and b 0. So you can't have 0 equals some other number. Okay? Then it's not even an equation. One of them could be, and not both of them, and the one that could be would be A. A can be 0, but B cannot be 0. All right? So I'm going to include that too. All right? Not only both of them are not 0, but also B cannot be 0. And I'm surprised that Dr. Berger, the guy who wrote the book, let that one go by. All right? So here's some examples of standard form. 5x plus 3y equals 20. Negative 9x plus 11y equals 3. 14x minus 2y equals 11. Or negative 10x minus 4y equals negative 6. For each of these examples I just showed, all of them have something times x plus something times y equals something. To talk about this b cannot equal 0, you can also have y equals 19. And that would be the same as if I wrote 0 times x plus 1 times y equals 19. So you can have this part equal to 0, but you can't have that part equal to 0. I'm not sure why they wrote it that way. Okay? So what to look for? We're going to ask you to identify linear functions. So the first thing is that you have to find the hidden exponent on x, which is equal to 1. Oh, I don't want to write that. Sorry, I don't want to think I wrote x equals 1. Whoops, sorry. If it's hidden, the exponent is 1. So like for all of these, if I wrote like 2x plus 7y equals 13, I have an exponent of 1 right there. And I know that that's confusing because we hide it. It feels like we just pulled that out of nowhere, like it's magic. And I'm sorry about that. Because when you learned exponents, hopefully you learned that if you don't see the exponent, that means you've got x to the first power. Okay? So what that means is any other exponent, sorry. That's what happens when I write and talk at the same time. I go too fast for myself. Any other exponent other than 1, it is not linear. Excuse me. So if you see x to the second power or x to the third power, anything like that, it's not linear. And we'll study what those are later. Okay, you don't have to worry about them. They are things, but it's just not linear. No x in denominator. And actually, I don't know if you're going to see it, but also it's true, no y's in denominator either. You can have denominators, you can have fractions, just you can't put x there. And also no x under radicals. So like that. The only radical that you guys know so far is the square root. There's others that'll show up later, but you don't have to worry about that. That's in algebra 2. Okay? So let's look at some examples, and we're going to see if we have a linear function or not. And I didn't write this in my directions. I'm sorry, I should have said that. We're going to put it in standard form. So if yes, then we're going to write it in standard form. Whoopsie. Okay, first one. So I have x with no exponent. If that's the case, that means that the exponent is the hidden 1. So that's good. I don't have any x's in denominators, and I don't have any radicals at all, so I don't have any x's under radicals. So I think this one is a linear function. So I'm going to say yes. Now let's put it in standard form. So standard form, I'll put it up here, was something times x plus something times y equals something. So it looks good. The y is on the left side, and I've got that number 3 on the right side. It's the x is in the wrong place. So I'm going to do y equals x plus 3. I'm going to add, I'm going to add the opposite of x to both sides. I said add, and I wrote a plus sign. And I'm going to get the opposite of x plus y equals 3. So I've got something times x, which is a hidden, there's another hidden number, the hidden negative 1. Something times y, which is the hidden positive 1, equals something. That's standard form. All right, let's look at the second one. This one, hopefully you guys are catching this. This is not linear because the exponent is 2. And I said if you see any exponent other than the hidden number 1, which you're not going to see because it's hidden, then it's not linear. And that's it. That's all you got to do with that. You don't have to put it in standard form because it's not linear. Last one. This looks a lot like that, where I've got y equals something times x plus something. So I'm going to do the same thing. Oh, sorry, I'm getting ahead of myself. Again, I have the exponent as 1. So yes, this is linear. and I'm going to take y equals 5x minus 9. All I need to do is put that 5x over here. So I'm going to subtract 5x from both sides, and I get negative 5x plus y equals negative 9. Move this up a little bit. I'm also trying to keep it centered for those of you who need to have it centered. All right, look at this. Y equals 12. All right. There's no x. What does that mean? Well, one way to write this would be 0 times x plus 1 times y equals 12. And if I do write 0 times x, it means whatever the x is, I'm just going to multiply by 0. So every y is going to equal 12. So whatever my x is, I get 12. X equals 1, I get 12. X equals 11, I get 12. So if I actually graph this, it's going to be a horizontal line. We talked about that in one of the previous videos. This is a linear function. You don't need to give me this, but so that you know, because I'm in teaching mode, I'll tell you that it's actually a horizontal line. And this is what it would look like in standard form. Something times x, and that something is 0, plus something times y equals 12. And that goes back to where we said a could equal 0, but not b. All right? So something times the x can be multiplied by 0, but not the y. Y equals 2 to the x power. All right. So I didn't mention this previously, and I threw this in here. I almost didn't do this one. This is actually, well, let me get ahead of myself. This is not linear, and you're not going to see this on the quiz or anything, but this is actually what we call an exponential function. And exponential functions are kind of cool because they look like this. Have you ever heard something's growing exponentially? That's what they mean. You don't need to know that. You're not gonna see it on the quiz. All right. Same thing with this one. This is not linear because you cannot multiply x times y. I mean, you can, but if you do it, it's not linear. All right. This actually makes a function where it looks like this: y equals 4 divided by x, and that goes back, if I divide both sides by x, and that goes back to you can't have any x's in the denominator. Okay, so looks like we saw 3 of them that were linear and 3 of them that were not, and we'll do more examples later. Ask questions in the discussion.